Logic 0, example 32.1, a proof that does not use indirect proof. All right, so this is starting out this chapter on indirect proof. And first of all, I want to show you how a proof can go if you avoid using indirect proof. And, and so let's take a look at that. We have this sort of problem to complete the proof, trying to prove neither C nor A from these two premises. In line 3, we can get A only if B from 1 by simplification. Okay. In line 4, we can rearrange line 1 so that we get C only if D and A only if B from line 1 by commutativity of conjunction. And then we can do De Morgan on line 2. And from line 4, we can take C only if D and simplify that. So now we've extracted from line 1, A only if B and C only if D as separate lines here. And we can, from line 5, simplify that to just not B. Whoop, this is line 7 coming from line 5. Okay. And then now we can use line 3 and line 7 to get not A from lines 3 and 7 by modus tollens. And here we see that we're going in the right direction because, of course, and sometimes this is helpful. So this is a little trick I don't think I've done in these demonstrations up to this point, but one way of working a proof is to kind of work it backwards. So you can see that if we get not C and not A, then we can apply De Morgan to that and get the conclusion we want. We have already accomplished not A. Now we just need to get to not C. And we can see here that we have not D in line 5, right? So if we do not D and not B from line 5 by commutativity, now we can simplify this down to not D from line 9. And now we can use line 6 in a way, a similar way that we used line 3, so that we get not C, which is, part of what we need to get to, from lines 6 and 10 by modus tollens. And now we can go to not C and not A from lines 8 and 11. Remember that the order of in our rules, the order of in our rules of inference, the order of the premises is not significant. So this is another place where we use that to put things in this order that we want them. We get that by conjunction introduction. And then line 13, as I was just discussing earlier, comes right from line 12, applying De Morgan. And we have completed our proof.